Welcome to today's edition of the Into Texas AI podcast. It's your look at AI news and trends impacting Texas. I'm your host, Shannon Ballou. Let's get started. Austin-based SMAC Technologies recently raised $61 million in Series B funding. Now, that's a notable technology story for the Lone Star State, but perhaps more interesting is what SMAC is building and who wants it and where the company fits within a much larger shift taking place across the American defense industry and the role Texas is playing in that industry. SMAC develops AI decision-making tools for the military. Its core AI platform, called Omega, is designed to help military units plan operations, identify possible courses of action, and adjust when conditions suddenly change. According to the company, Omega is currently moving into production across multiple branches of the U.S. military. SMAC says Omega uses reinforcement learning and real-time computer vision to generate options in minutes and repair disrupted plans in seconds. The company is also developing Alpha, a flexible forearm display intended to put AI-assisted information directly in front of service members operating in the field in real-world conditions. Now, this is a very different AI environment from the one most businesses are used to discussing. These systems may need to operate with limited computing capacity, unreliable communications, and sometimes incomplete information. And the decisions they support can carry enormous consequences. The Department of War calls much of this AI at the technical pause. The Department of War calls much of this AI at the technical pause again. The Department of War calls much of this AI at the tactical edge. The basic idea is that intelligence and decision-making capability must move closer to where operations are actually happening instead of depending entirely on a distant command center or cloud computing system. The Pentagon is investing heavily in that capability. And Texas has a growing ecosystem of AI defense companies that are supporting the efforts of the military. And that's what we're talking about today on this episode of the Into Texas AI podcast. AI defense spending in the U.S. There's not one universally accepted number for the size of the defense AI market. Some research firms count only AI software as part of that. Others include a lot of the other hardware and equipment, which means drones, military robots, autonomous vehicles, sensors, even communication systems, and the computing infrastructure supporting all of them. Now, one commercial estimate values the U.S. military AI market at approximately $2 billion as of 2024 and projects it will reach $3.2 billion by 2030. But that estimate captures only part of what we are discussing. So we turn to numbers coming directly from the Pentagon to really help kind of set the stage of what we're talking about. And for fiscal year 2026, again, the Department of War requested $13.4 billion for autonomy and autonomous systems. It was the first time the Pentagon separated autonomy into its own budget category. Approximately $9.4 billion was intended for unmanned and remotely operated aircraft. Another $1.7 billion was directed toward autonomous systems operating on the water, with $734 million for underwater capabilities. The Pentagon also requested $1.2 billion for the software that allows these systems to operate, coordinate, and make decisions. And within that broader total, approximately $3.1 billion was requested specifically for counter-drone technologies. And we'll talk about that in a bit as well. So even if we cannot put one clean, solid number around the entire market, it does seem clear that defense AI and autonomy have moved well beyond experimental research programs. The military is beginning to fund them as a distinct and increasingly important category of capability. SMAC's $61 million funding round is closely connected to all of that urgency. In fact, SMAC's CEO, Andy Markoff, recently told Reuters that the Marine Corps and Navy began pressing the company to accelerate production this spring. The concern is that a future conflict involving a major military power would look very different from the conflicts that the United States fought in Iraq and Afghanistan. It's becoming a more decentralized environment, and more decisions will have to be made locally and very quickly. SMAC already has two prototyping contracts SMAC already has two prototyping contracts involving the Joint Forces Network and the Marine Corps Warfighting Lab. SMAC already has two prototyping contracts, including one with the Marine Corps' Warfighting Lab. Those contracts focus on SMAC's Omega platform and its ability to improve what the military calls the kill chain, the process of identifying a potential target, determining what resources are available, and then coordinating a response. The company has also been working on a Navy prototype agreement related to maritime operational planning. Now, that distinction between funding and contracts is important. Venture capital tells us that investors believe there may be a large future market and they're willing to put money behind it. A military contract tells us an actual customer is willing to test or purchase the technology and hopefully put it to use. SMAC now has evidence of both. The Texas Defense Foundation. The defense AI ecosystem in Texas is not coming from out of the blue either. The state already has one of the largest established defense economies in the country. The Pentagon's most recent state-by-state comparison found that total Department of War spending in Texas reached $71.6 billion in fiscal year 2023. And now that is the most recent report that we could find. And that was also the highest total of any state that year, even ahead of Virginia, which was at just over $68 billion, in California, just under $61 billion. Now, we should be really clear about what, all these numbers means, right? So when we talk about that entire $71.6 billion, it was not contract spending alone, right? It included $58.7 billion in defense contracts, but then also approximately $12.5 billion in military and civilian payroll, and then another $393 million. Still, we find that the number is really impressive. And more recent analysis from the Texas Comptroller gives us another way to understand that foundation of the state's defense industry. In 2025, so this is a more recent report, in 2025, Texas military installations generated an estimated $148.8 billion in economic output and contributed $91.4 billion to the state's gross domestic product. They also supported nearly 629,000 direct and indirect jobs across Texas. Now, those numbers do not tell us, how much of that activity involves artificial intelligence specifically. So I don't at all intend for us to use them to claim that Texas leads the country in defense AI. However, it does show the enormous defense workforce and customer base surrounding this younger AI and autonomy-based companies that are now growing here in the state. And we can't overlook that Texas also has major military installations here, and then also established defense contractors that include Lockheed Martin, Bell, Raytheon, which is now, I think, RTX Corporation, and Elbit America. So not to mention, there's plenty of engineering and manufacturing talent as well. We have university research here, lots of military customers in the state, and an existing supply chain. So I think together that helps explain why the current defense AI activity isn't happening in isolation, right? We've set up this foundation to help it grow and prosper. Now, I think what may be the more interesting question is what these newer companies are building on top of this established defense foundation in the state. And when we look more closely, we find that the Texas ecosystem is becoming much broader than, drones alone. Cesium Astro adds space autonomy. All right, so one of these examples comes from a company called Cesium Astro. Just days after SMAC announced its new round of funding, Texas based Cesium Astro announced the acquisition of One Aardvark, a Virginia defense software company that specializes in mission software, edge processing, distributed architectures, and autonomous systems. Now, that acquisition is important for Cesium Astro, which is headquartered in Bee Cave outside Austin. That company designs and manufactures satellites, communications payloads, and advanced computing systems. One Aardvark software is designed to help distributed defense systems coordinate and continue executing a mission when communications are limited or they're disrupted or just completely unavailable. This includes work related to missile tracking and missile defense. In practical terms, Cesium Astro is trying to build spacecraft and other systems that do not simply wait for instructions from the ground. They need to be able to interpret what's happening, adjust to changing conditions, and then continue operating with a greater degree of autonomy. Cesium Astro has acquired two other companies this year, including one that is focused on analyzing data in real time, and then also a semiconductor company. Taken together, Cesium Astro is bringing communications hardware, advanced computing, semiconductors, real-time AI analysis, and autonomous mission software into one Texas headquartered company. In fact, it's making a substantial physical investment here as well, including in nearly 270,000 square feet and located in Bee Cave for an expanded global headquarters and manufacturing operation. It expects to invest approximately $500 million over 5 years and add roughly 550 Austin area jobs, bringing its local workforce to more than 1,000 employees by 2030. Operations at the expanded facility are expected to begin in phases, with the larger manufacturing operations scheduled to come online beginning in roughly 2027. Autonomous systems on water and in the air. Now, there are some more familiar companies that we've covered previously on our Into Texas AI podcast, but I think they're worth another mention here as part of this broader story. Saronic and Shield AI both help show how Texas is combining autonomy software with physical manufacturing as part of this growing AI defense industry. Austin-based Saronic is building autonomous vessels for military and commercial use. It was founded in 2022 and has established manufacturing operations in Austin. Its vessels are designed to perform surveillance, logistics, and other missions with fewer people physically on board, or in some cases without crew at all. It also acquired a Louisiana shipyard, and then in July of this year, along with Governor Abbott, announced plans for Port Alpha, which is a more than $3 billion autonomous shipbuilding complex at the Port of Brownsville. Now, that facility is expected to begin operations in 2028 and comes with approximately 10,000 employees. Okay, so let's also jump up to North Texas, where we're talking about another company we've covered before, and this is Shield AI, which manufactures and tests its VBAT aircraft. They're in Frisco, and it develops portions of what's called HiveMind, which is its AI pilot software. HiveMind is designed to let aircraft operate without a human pilot, including in environments where GPS or communications are, again, unavailable. This month, Shield AI reported that 3 Taiwan-built drones used the software to complete a coordinated search mission without any human pilots controlling them. Now, while Shield AI is headquartered in San Diego, California, its Frisco, Texas location is a 107,000 square foot facility that serves as the company's primary manufacturing and testing hub, which is commonly referred to as the Bat Cave. Together, Shield AI and Saronic give Texas meaningful positions in autonomous systems, operating both on the water and in the air, and in the physical capacity that's required to build and deploy them. Now, let's talk about the counter-drone concentration. Texas is also developing a more concentrated counter-drone sector. In fact, Austin based Allen Control Systems makes Bullfrog, which is an AI powered robotic weapons station designed to identify, track, and shoot down hostile drones. The company recently received a $6.2 million core contract and announced that it was tripling its Austin footprint to more than 57,000 square feet. Several younger Austin companies are also approaching a similar type of problem. Vigil Autonomy is developing AI models intended to help counter drone systems distinguish a threat from a bird or background clutter or even a friendly aircraft. You also have Lantern UAS, which is working on drone detection and decision support software. Another Austin startup, Nine Mothers, is developing an autonomous system intended to stop smaller drones at close range. Some have contracts and systems already in testing, while some of the other companies we've mentioned really do remain very early stage, but I think they're still worth watching. Now, we also know that at least 8 companies with Texas operations are now developing some part of the counter drone market, including detection software, computer vision, automated weapons, and lower cost interceptors. The Pentagon expects to spend approximately $3.1 billion this year on counter drone technologies. That creates an unusually direct market opportunity for the companies already forming around Austin and Central Texas. Okay, now we need to talk about the elephant or the frontier model in the room. While Texas has an opportunity to play a larger role in AI defense than it has in, say, the consumer AI or frontier model markets, there is another issue we have to address as this market grows. What AI models are actually being used inside these What AI models are actually being used inside these defense systems, and how secure are they? The Pentagon is increasingly adopting commercial frontier models for intelligence analysis, operational planning, logistics, software development, and decision support. But using a frontier model in a national security environment creates risks that are much more serious than, well, receiving an incorrect answer from a consumer chatbot. You know, when you're talking about defense, right, a model could misinterpret incomplete or intentionally manipulated intelligence, and sensitive information could be exposed through the model, its training data, or the systems connecting it to classified networks. The model could also become vulnerable to an adversarial attack. Frontier language models introduce another problem as well. Much of the technology is controlled by private companies that set their own usage policies, update their models, and determine what kinds of activity their systems will permit. That can create a supply chain dependency in which a military capability relies on a model that the government does not completely control. The Pentagon's recent dispute with Anthropic, for example, put that exact issue on display. Anthropic's Claude became the first frontier model approved for use on classified networks under a contract that came with some guardrails. No use in fully autonomous weapons systems that select and engage targets without a human involved, and no use for mass domestic surveillance. When the Pentagon later pushed to remove those restrictions and use Claude for, in its words, quote, all lawful purposes, Anthropic pushed back, refused, and just didn't want to drop those clauses at all. Now, that refusal escalated quickly, as you can imagine. The administration ordered federal agencies to stop using Anthropic's technology, and the Pentagon designated the company a supply chain risk, a label that's typically reserved for firms tied to adversarial nations, not American AI labs. If you remember following this earlier this year, you know that what happened next is that Anthropic sued, arguing that that designation was retaliatory and not valid. A federal judge has since blocked that designation, and the fight is still working its way through the courts. So this hasn't played out yet, but it hasn't kept everything from moving forward. Now, this is a big topic for a lot of people. We all have our personal opinions about what this means, and we all have a lot of at stake with it, obviously. But whatever your view of that dispute, it did expose a much larger unresolved question. Who ultimately governs a frontier model used for national security? The military purchasing it, the private company developing it, or some combination of the two? And what happens if the provider changes its policies, withdraws access, or releases an update that changes how the system behaves? Now, that said, we need to be clear. Defense AI does not automatically mean that ChatGPT from OpenAI or Claude, which comes from Anthropic, or any other commercial large language model is actually being used in its systems or products, whether it's to control a drone or select a target or direct a military operation. In fact, the companies that we've been talking about today actually appear to rely primarily on more specialized systems. SMAC, for example, describes its models as proprietary and domain specific rather than general purpose frontier models. It says they are grounded in military scenarios, the physical constraints of warfare, and the judgment of very experienced service members. SMAC is also developing a smaller model called Diet Cage that is designed to operate on local hardware at the tactical edge without a persistent cloud connection. That, of course, reduces dependence on an external model provider and it limits the need to transmit battlefield data back to a remote server. SMAC also describes its architecture as vendor agnostic, which we very much supported into Texas, and that could reduce reliance on any single technology provider. SMAC has not publicly disclosed detailed information about its adversarial testing or cybersecurity controls or classified data handling or even the specific process used to validate model recommendations before they reach an operator. Some of that information understandably remains confidential. Cesium Astro has also emphasized AI that runs closer to the physical system. And while it also has not publicly identified which foundation or frontier models, if any, are incorporated into these systems, it has also not provided any detailed public information about AI red teaming model validation or the boundaries placed around autonomous decisions. Its government contracts will carry security, performance, and testing requirements, but the public record does not give us enough information to evaluate how those protections are implemented. Allen Control Systems, they actually provide a more explicit answer on human control. Its Bullfrog system uses computer vision to detect, identify, track, and acquire a potential drone target. According to the company, a human operator must still give the actual command to fire. The AI can perform much of the detection and targeting process autonomously, but that final use of force decision remains with a person. Bullfrog uses proprietary computer vision and control software rather than a publicly identified commercial frontier model. Now, that does not eliminate the possibility of misidentification or manipulated sensor inputs or any type of software compromise, but it does create a defined point of human authorization before the system fires. The Pentagon's official policy requires autonomous and semi autonomous weapon systems to allow commanders and operators to exercise an appropriate level of human judgment over the use of force. It also requires those systems to demonstrate reliability and effectiveness under pause. It also requires those systems to demonstrate reliability and effectiveness under realistic conditions and comply with the department's responsible AI principles. The challenge, as always, is moving from policy to proof. Companies will need to demonstrate not only that their systems perform well during a controlled test, but that they remain trustworthy when communications fail, when sensor data is manipulated or software is attacked, or even when the operating environment changes in a way that the model has never encountered. Okay, as we close out today's episode, I'm reminded that no matter what part of AI we discuss, a common question is always hovering above the conversation. How much decision-making authority should be delegated to a machine? And when it comes to defense, the question becomes what human oversight is required when an autonomous system can identify, track, or engage a target? Perhaps more importantly, how do we judge reliability when failure can carry consequences far beyond a bad business recommendation or an incorrect response from a chatbot? Those questions should not be separated from the growth story either. I really believe that. It's part of it. And as always with AI and all the stories we cover, when we talk about guardrails and governance and human in the loop, right? This is an important piece of the entire story and how we approach and grow these companies and grow these industries. So it's all very much connected. I think that the companies that succeed in defense AI may not be the companies with the most advanced models or AI enabled hardware. Maybe the most successful ones are those that can demonstrate reliability, security, interoperability, and clear human control under extreme conditions. We'll have to wait and see, as always. As for the role of Texas in the industry, well, the state may not necessarily lead this market, but it has a solid foundation to support the growth. Not only is it one of the largest defense economies in the country, but the state is also actively attracting substantial private capital, building specialized companies, expanding manufacturing capacity, and bringing additional autonomy capabilities under the control of these Texas-based businesses. And that makes defense AI one of the Texas stories that's worth keeping an eye on. That's it for this episode of the Into Texas AI podcast. As always, thanks for joining us and taking the time to listen or watch. And if you want more insights on how AI is reshaping Texas, please continue to tune in and subscribe. I would appreciate it. I'm your host, Shannon Ballou. I'll see you next time.